Hello, my name is Javier Canto and today I'll be showing you the key project I did for Physics 2. My key project is an experiment on maximum height on kicks. One of the most important aspects in achieving a field goal is the maximum height the ball reaches. Knowing that, I decided to do an experiment in which I analyzed the maximum height a ball reaches after being kicked at 3 different elevations. I've decided to do this experiment because by knowing the results of my experiment, many teams will know, and people will know the altitude in which they have a higher chance to obtain a field goal from a further distance. The theoretical mark. The longest field goal was a 64-yard field goal, and it was made at a 1,585-meter altitude at a negative 11 Celsius degree temperature with 3 miles per hour winds to the south and a 72% humidity index. However, the second longest field goal was made at an altitude of 5 meters. It was a 63-yard field goal. Well, this happens due to the low density of air at high altitudes, and due to this, the height range of my kicks will variate. Identification of the variables. The dependent variables will be the altitude of the city, the air humidity, the temperature, the initial speed of the kick, and the angle of the kick. The dependent variables, well, the only dependent variable is the maximum height of the kick. The only controlled variable will be using a Wilson football, and the only two control conditions will be the footwear the kicker uses and the altitude in which the kicker kicks. The experimental design. My experiment will consist on kicking a football into the air and using a tracking software, in this case Tracker, I will calculate the maximum height the football reaches at 3 different elevations, which will be 2,667 meters, 1,510 meters, and at sea level. Well, due to the coronavirus pandemic, I will be limited to do the experiment only at 2,667 meters. And using the information, I will attempt to predict the altitude, the height the football will reach under those 3 different altitudes. The experiment will take place in 2 sessions of 30 minutes, 1 per day. And during every session, I will execute 6 kicks. Every kick will be recorded and using the tracker software, and I will analyze the height of every kick in order to calculate the median, the mode, the quartiles, the interquartile range, the standard deviation, the variance, and to get an average of the height of every kick. I am planning to do the sessions between 2 p.m. and 4 p.m. because according to the Weather Channel, in those hours, the wind and the humidity index are at its lowest during the day in Metepec. For the sessions, I will use the Nike Hypervenom Vortex Turf Champions League tennis shoes from 2016 because those are the tennis shoes that can bring the best results due to the shape of the pump. After recollecting the information, I will use the settings of other altitudes and I will predict the height the football will reach under those situations. The materials I will use will be a Wilson football, a camera, which will be my iPhone 6s, and a tracking software, which will be Tracker. Now, I will show you the experimentation process. Well, here you can see the results I got from the experimentation process. Here you can see the maximum height of every kick during day 1, along with the initial speed of every kick and with the angle of every kick, the average of the day 1 kicks, as well as the median, the mode, the mean, the range, the standard deviation, the variance, the quartiles and the interquartile range. As well as you can see the information on day 2 of every kick, the maximum height of every kick in meters, the initial speed in meters per second of every kick, and the angle of every kick. So you can see the maximum height average of all the kicks in day 2. As well as you can see the mean, the median, the mode, the range, the standard deviation, the variance, the quartiles, and the interquartile range information of day 2. And here you can see the total maximum height average of both days in meters, which is 7.2074 meters. Well, the moment of the truth has arrived. These are the final results I got. But how do I got them? Well, first I had to calculate the effective oxygen percentage of every altitude. At sea level, you got a 20.9% of effective oxygen. At 1,510 meters, you got a 17.14% of effective oxygen. And at 2,667 meters, you got 14.40% of effective oxygen. Well, as I already knew the height of 2,667 meters, I used the height that I got at that height, and I adapted the height to the other effective oxygen levels. Well, as you can see here, you got a higher height at a higher altitude because of the percentage of effective oxygen. Well, conclusions. Well, if you're attempting a long field goal, you have a higher chance to achieve it by attempting it at a higher altitude. That conclusion was made from the results I got from my experiment. These are my references, and well, this was my final project of all high school. Thank you a lot for seeing it, and I hope to see you again soon.